Hi guys, I'm Bogdan Maxim. I work for EveryMatrix. We are an internet gambling company. Um, and this talk is about event streaming and processing. We're gonna go first through a short introduction. Actually, it's a longer introduction and some historical facts. Then we're gonna talk a bit about real time and then how it started for EveryMatrix and how we started using or doing event streaming and processing. Now, I'm going to have some questions for you. Just please raise your hands. How many of you work in a company that has, let's say, more than 5 departments? Okay. Does any of you know what the guy in finance uses to run his cash flow reports? Okay, no one? No one. Okay, but yeah, so you're having more than 5 departments, most of you. Does this mean that you have a lot of applications, a lot of systems that are connected to each other? How many of you? I don't know. Okay. What about integration? Are these applications integrated with external software? Okay. Yep. Do these applications do any kind of data processing, like, I don't know, reading data from somewhere, writing it, doing something? Okay. Okay, what about large databases? Let's say more than 1 terabyte. Oh, good. So, how does an enterprise look like? Usually, it is split in some, let's say, management branches, which you can call them departments, that do different business operations. So, what is a business operation? Finance, marketing, accounting, sales, core business. And how does your environment look like with the systems and the applications? You have 1 or more applications that actually are the base of your business, and some other connected applications that do some data processing and support the other departments to do the daily stuff. So this is the usual enterprise. We would have a few departments: operations, sales, technology, infrastructure, etc. Also, we'd have the core business, which, again, is the base of the business, and some external partners, which help us do our own business. This is what an environment of for the applications would look like. So we would have, let's say, for a website that sells products, think Amazon but smaller. We would have, let's say, 3 lines of business applications, one that does user management, the other one does order management, a website which our customers can access, and then we would have other applications like business intelligence, ERP, CRMs, monitoring, and some external providers for the call center because we don't have enough money to hire 100 people. Some shipping suppliers because we need to send our products to the customers, some product suppliers because we need to get those products that we are selling from somewhere. And these applications are connected. We have these black lines. They are data dependencies between the applications, but they usually don't look like this. This is actually a pretty diagram. They look more like this. They are quite intertangled and messy. And whenever anyone starts integrating an application, basically starts adding more stuff and more stuff, cutting from somewhere. Now, there are some elephants in this room, and the elephants are the reporting applications. So usually, what do we do for business reporting? We use ERPs. We may have some sort of reporting application that we are using, and we would have some sort of business intelligence application that helps the business with the decision process. Now, to get data into these reporting applications for the last 10, 15 years. Everyone with serious needs has been using ETL. It's actually a pretty standard process. And they get the data from the original applications, then process it and transforms, and then moves it to a data warehouse from which the data gets processed, and then it's provided to the users via cubes and data marts and reports. How does ETL look like, and how does ETL work? It gathers the data, processes it, moves it in batches. And when does this happen? OK, I seem to have some problem with the slide, but when does it happen? Every few minutes. For example, maybe 5, maybe 10 minutes, maybe 1 hour, maybe 10 hours, depending on the quantity of data that you need to collect, depending on the quantity of data that you need to process, and some other facts. What comes after the data warehouse? And it's a big elephant. Actually, it's more elephants, and instead of, for example, needing one room because you had the reporting applications and the BI, now you have multiple data sources, you have very big databases, you need to collect that data and store it. What comes with big data, except of a rate, let's say, of failed projects? It comes the Lambda architecture, and the Lambda architecture basically combines batch processing with real-time processing, and does it via MapReduce, via incremental processing of data, and gets the data into materialized views. Now let's talk a little about real-time. So you would say, OK, my system works perfectly. I like the way my batches work. Why would I need something else? First, it would be the business environment. Businesses need to take decisions faster. They need to react to a changing business environment, again, very fast. Also, there might be some impact on your applications when you are getting the data in batches from your databases, and also you would have to integrate with a lot of other vendors because basically you want to be flexible and you want to change them whenever you feel like the vendor doesn't help you with something. Batches usually work by pulling data. They create some strains on the databases. They can be of multiple types. You can get full database dumps. For example, if you need to initialize a system, you would need some sort of full database dump. Otherwise, you would need to get only the differences between the data. And these things can reduce performance. Now, there are some use cases for real-time processing. These are a few domains. In finance, you would need, for example, to know, OK, what are my losses at this moment? How much money do I have in all of my accounts? How much did I sell today? In gaming, think about if you were to play an online game, you wouldn't be able to do it in batches because you would play the game for 15 minutes, for example, and then you would need to wait for those 15 minutes to get a result, which is not very fun. Then we would use it for monitoring. We need to be able to monitor our systems. We need to be able to get alerts in real time, etc. Now, there is something we would need to think of the definition for real-time processing, which is quite hard to get it. From, let's say, the dictionary, a lot of people will say, OK, it's on the fly. It happens now. It's happening as we speak. OK. So in order to be able to easier define this real-time, we would need to define some dimensions for real-time processing. And these dimensions would be the complexity. What exactly do I need to do? And we can look at them as simple aggregations. We need to know the sum of, I don't know, the amount of money that we have in the accounts again, the number of transactions that we did, or we would like to see the trends. Are our sales increasing? Are our sales decreasing? We would need to be able to classify this data, to do some recommendations based on the data. What do our users want? What do our users would like to buy based on what other people are buying? And maybe do some predictions like, I don't know, what will my sales be tomorrow based on the volume that I have today? We would need to look at the latency, and basically the latency tells us when do we need the data. And we would have at least 5 dimensions for latency. We would want the data now, or in, let's say, a couple of milliseconds. We would want it in a few seconds, maybe in a few minutes, days or hours, or maybe weeks or months, depending on the needs. Also, there are some other things that we have to take into consideration when thinking about real-time processing. One thing is the event data rate. If we have applications that are generating events, if this event rate increases, then we're going to need to develop our applications to be horizontally scalable. And if we would look at the event complexity, event classes, given that we have multiple applications, we would need to be able to process and find relations between these events, and this can increase the processing complexity. Now, there is something called processing latency. After a lot of discussions with, let's say, business people, I've come up to the conclusion that we can define the real time, we can split it in three parts. One is hard real time, which is, it happens right now. It happens during my processing, during my transactions processing. It happens in soft real time, which can be in a matter of seconds, maybe milliseconds, but usually a matter of seconds. Or in near real time, which could be minutes, or I don't know, it couldn't go, let's say, it would not go to more than 15 minutes. And non-real time, basically, it would be in hours or days. There are some good practices that, when thinking about a real-time system, that you would have to take into consideration. One, it would be to establish a common semantic or dictionary with your customers, so that everyone knows exactly what we are talking about. For example, some people are using near real time for seconds, some other can use it for minutes latency. And that can create confusions and, let's say, not confusions. Yeah. OK, so how did it start for us? What is GamMatrix? First, GamMatrix is our platform. It's the platform of EveryMatrix. What we do with GamMatrix, basically, we handle transactions and player management, given that EveryMatrix is a gambling operation mostly. And we have a lot of integrations with gaming vendors. They are down on the image. We have a lot of systems that are integrated. We have payment processing systems, again, that are plugged in our system. And why do we have all of these? Because we are mostly a business-to-business company. And most of our customers actually want to use their own systems. They want to use their own providers. They they might not need a full solution for all of their operations. So for us, it started with the CRM integrations. We needed to be able to support multiple CRM systems, which have different data structures across different vendors. And the data that we need to get there is user profile data and some financial data related to those players. So What data do we get there? New users, session activity, the players are logging in, they are playing games, they are updating their profiles, they are making payments, they are using their money, they are winning, they are losing. They can exclude if they have problems with, if they have gambling problems. Also, some of our customers are tagging their players based on this information. For example, a VIP would be a player that creates us a lot of revenue, or a casino player would be a player that likes to play only casino games, sports that goes only to sports betting and other things like this. Now, our initial implementations were mainly based on jobs. They were exporting data directly from the database. We had multiple data sources, so two databases at least, the one for transactions and the one for users. Also, we were getting some data from the reporting system, like the revenues for that player, and some casino-based information for, in order to know which games the players are playing. Normally, these were integrated as file uploads. This is what almost everyone does. But some of them have started supporting API connections, and this can change the requirements a little bit. Now, we had some problems with these, given that we had we had the same sources and different problems and different vendors, and each vendors had different data structures. We had to base our data processing on the vendor data structure and basically maintain different code for different integrations on the same database. So this is what we've got now. The high-level view, basically the steps are we generate all of the events from our core application. Then we are setting these events on a message bus or a streaming platform, after which the data gets aggregated into something that we standardized. It's more easier to handle like that. Then we save this standardized data into temporary storage. And after that, we generate more events. And after we generate these events, they are picked up by the integrations with the vendors, with the CRM vendors, and basically they go either via the file upload or via the APIs in real time, depending on what the vendor supports. Now, we had some implementation requirements. One was that the data streaming should not affect the transaction processing time. This means that we decided not to wait to receive a confirmation from the data streaming platform, but we are doing some buffering in memory. And this can cause some problems. We'll talk about them a bit later. And that another requirement was that the data should be consistent at the destination in case of server failure. This is a problem generated by the first requirement. Now, this is what we got to. We have our own, we have our application servers, our database. The application servers are processing the transactions, are writing them in the storage. Then, at the same time, the data gets streamed into Kafka, and we had to implement a reconciliation process. Now, if one of these servers were to fail, what it would happen? We would lose some of the real-time messages, and we would have to rebuild them somehow. For this, we implemented a reconciliation process, which goes to the database, checks for the differences, checks for new data or data changes, and then rebuilds the messages into the streaming platform. From there, the data can be picked up by multiple consumers. It's the same data for all of the applications in the whole company. So if we would want to send this data to a reporting system, the reporting system would be able to pick it up and create some reports based on it. Same thing for the CRM integrations. If we would want to send some notifications in real time based on user actions, we would be able to do that by reading these messages. And that's it. Now, questions and answers. Okay. Response time. Okay. One moment.
I didn't see it because of the wall, so okay, you already got it. Okay.
Can you hear me? Yeah, okay. I was very curious about your response time. You were talking earlier about about real time and latency and things like that. Can you give us a few words on how is your application characterized in that way?
Okay, so if we look at our transaction processing times, they are usually around 200 milliseconds. There are a lot of things that get processed during those 200 milliseconds. For data that gets into the CRM systems, the delay, the latency is somewhere to, let's say, 50 milliseconds, depending on where the vendor is hosted. So if it were to be, let's say, in Google Cloud or in some data center in Europe, our data center being in Romania, this would amount to those 50 milliseconds. So this is what we've got.
Do you compute anything with the data that you get in, or do you have any processing of that data before you send it further?
Yeah, so we have that intermediary state. That intermediary state contains data related to the deposits that the players have made, related to the amount of transactions, so the count and some sums. And they get updated with each events that are coming.
Thanks.
Someone else? Okay. Thank you so much, Bogdan.
Thank you.